Hello everyone. In the previous lecture or lecture 1 first part, we have discussed about the basic principle of counting. Now we'll discuss about the permutation. So maybe we all know that a permutation of a set of some distinct object is an ordered arrangement of this object. So basically you will arrange some object where the orders matter. We'll have a lot of example anyway. An ordered arrangement of R element of a set is called an R permutation. The number of R permutation of a set with n element is denoted by PNR or NPR. And this content can be found using this basic principle of counting or the product rule. So suppose you have three objects A, B and C. So how many different ways you can arrange them? See, here A, B, C and B, A, C, these are the different arrangement, right? So therefore this order matter. Whereas if I just ask that a set you have, so in a set if you have A, B and C, three element, and if somebody said that I have three element B, A, C, are they not same in case of a set, right? So if I just select some elements, then order does not matter. But if I say that arrange some element, then A, B, C and B, A, C, these orders matter, right? So the question is, how many different ways you can arrange them? Now, you can count this arrangement with the help of product rule. So you have three elements. So you have basically three positions available. How many elements you have? Three elements you can choose. So for the first position, how many different choices you can have? You can have three different choices. You can take A, you can take B, or you can take C. So there are three possibilities. Now, for the second position, to fill it up, one is already taken from this list. So for the second position, how many available? There are two possibilities are there. And for the third case, you have already filled up with the first two positions. So 2 has been already taken from this list. So there are only one choice left. So altogether there are 3 into 2 into 1. So 6 number of different arrangements are possible. So which is basically a 3 permutation. So one a particular example is BAC. It is one kind of arrangement. ABC, CAB. This is another arrangement. So this way if you try to arrange, we'll have 6 different possibilities. So this is called the permutation, right? So this is an ordered arrangement of 3 elements of a set, right? And it is called the 3 permutation in this case. Now, if you generalize this concept, right, and we have n number of object, and we want to arrange r number of element from this n object. So how many different ways you can do? That is called the number of r permutation, which you denote it by PNR or you denote it by NPR. Now you must have understood that if I apply the generalized principle of counting, basic principle of counting, we can easily understand that how many different ways you can have. So because you want to arrange r number of elements from an n element set, so you will basically have r number of positions. You basically have r number of positions, right? So for the first one, how many choices you will have? You will have n number of choices. Now once you have filled up the first one, how many choices you will have for the next one? You will have n minus 1 number of choices. And in this way, if you move on, right, for the last one, how many possibilities you will have? Think of it, make the video pause and write down that. Yes, it should be basically n minus r minus 1 number of possibilities, right? So this is same as n minus r plus 1 number of possibilities. Now if I apply the basic principle of counting, the generalized version, So how many different R permutations are possible? It is n into n minus 1 into dot 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 up to n minus R plus 1 number of possibilities. This is called the R permutation of a set, number of R permutation of a set with n elements, denoted by P and R. Correct? So this is what, if n is a positive integer and R is an integer with 1 less or equal to or less or equal to n, then there are P and R equal to n into n minus 1 into n minus 2 to the n minus R minus 1 R permutation of a set with n distinct element. I hope this is very clear. So permutation is just an application of the basic principle of counting or the product rule. We'll do several examples. It will be very clear to you after that. However, now look at this expression, PNR expression. We can just simplify this expression and we can have that n factorial divided by n minus r factorial. If I simplify this, this is same as this experiment. This is same as this experiment. Correct? So n factorial divided by n minus r factorial is that. So therefore, we can write that if n and r are integer with 0 less or equal to r less or equal to n, then p n r is equal to n factorial divided by n minus r factorial. I hope it is clear. Okay. Then the number of permutation of n different element is n factorial. Yes, here in the previous case we have taken number of r permutation. That means each of we are going to arrange for r number of elements from an n element set. Here we are asking that all n elements you can take and you have to arrange how many different ways you can do. So this is basically n into n minus 1 dot dot up to n minus n minus 1. Correct? So this is because here r is equal to n and therefore it is equal to n factorial. Now this example we have already discussed how many permutations are there of the letters A, B and C. So there are 3 elements and you have to arrange them how many different ways you can do. Now we know the formula, permutation formula. So this is basically 3 factorial is equal to 6. So therefore there are 6 number of permutations are there. Now I'll give you some example. Think of it and then you see the video again. So read the question carefully. A printed circuit board has 8 different locations in which a component can be placed. If 4 different components are to be placed on the board, how many different designs are possible? So think of it, there are 8 different locations are there and 4 different components are to be placed. Right? So what should be the answer of it? Make the video pause. Think of the answer. You can write down the answer in your notebook or in the comment box. Until you do, you will never learn this mathematics. So please do it. Yes. See, for each of the component, you consider them as, to assign them their location, you think them as experiment 1, experiment 2, experiment 3 and experiment 4. So for the first component, how many different choices you have? So you have 8 different locations you have. You can put the first component in any of the 8 different locations. But once the first one is done, for the second one you have only 7 locations are possible. For the third component you have only 6 because 2 are already filled up. The third one you have 6 and for the fourth one you have 5. So altogether it is 8 into 7 into 6 into 5. And now we know the formula. So this is basically a 4 permutation for a with a set of 8 elements. So how many ways you can do? It is basically P8, 4 which is same as 8P4 and which is same as this quantity. Which is same as this quantity. I hope it is clear. Yes, that is what we discussed. So there are This many different designs are possible. Now think about this example. How many different batting orders are possible for a baseball team consisting of 9 players? Very easy. One line answer. Yes. So each of the batting orders basically mean that one permutation of 9 players. So whenever you will change the different batting order, then you will get a different permutation of these 9 players. So how many ways you can do? Yes, certainly the answer is 9 factorial. Okay, let me move to the next example. Yeah, this is what we have discussed. There are this many possible 9 factorial possible batting orders are there, whose answer is coming out to be this one. Okay, let me move to the next example. Yeah, look at that. 4 names are drawn from among the 24 members of a club for the offices of president, vice president, treasurer, and secretary. How many different ways this can be done? So now you know the formula. This is basically the assigning office for the president, vice president, treasurer, and secretary. So how many different ways this can be done? Yes, so you may think it generally, or now you know the formula. So this is basically 24 P4. So always, whenever I'm showing you some example, make the video pause, think the answer by your own, write down it in your notebook or in the comment box, then try to match the answer with me so that you will learn. I repeat, unless you do by your own, unless you solve by your own, you will never learn mathematics. Correct? So kindly do that. So the answer is this one, as we already discussed. Let me move to the next example. Okay. Now, a new concept I wanted to discuss called the circular permutation. So permutation we have understood that, okay. So you will have some arrangement of R number of elements from an n element set. What if this arrangement, if you do it in a circular way? What does it mean? Sometimes we need to do that arrangement in a circular way. Let me give you an example. You know the carom board, right? You used to play carom. 4 people used to play, right? So there are 4 participants, 4 players, A, B, C, and D. Now, how many different way you can arrange them to play the carom? Now, see, in case of a carom board, A, B, C, D, this is what you will place. This is one kind of arrangement. Whereas, if I say that the D, A, B, and C, can you tell me, in case of a carom, is there any difference between them? Is there any difference between these two? No, no, because A and C may be getting paired with each other, or A and C are sitting opposite to them, and B and D are also sitting opposite to each other. So in both the cases, they are same, right? So in this case, you cannot say that how many different will do, and you will say that 4 factorial. No, it is not the case, because in this case, this kind of things are same. This kind of examples are same. So what will be the case? How many different ways you can make this arrangement? So think of it. Some of you may know the formula of circular permutation. How many are possible? N elements are there. How many different circular permutations are there? Maybe you know the formula, but what should be the logic behind that? See, as I mentioned that both the cases are same. So you have to fix one position. Maybe you fix the position A. You fix the position A. And then you change the other 3 element here and there. You will get different one. So D, A, C, D, B, C, sorry, D, B, C. So this is a different one, right? D, B, C. This one is different. Again, because you have already fixed the position A, and then you changed it C, D, B. These are different, right? These are different. So therefore, once you fix the one position, Therefore, once you fix one position, then other three you can do the permutation. So how many ways you can do the permutation of three elements? You know already, it's a 3 factorial ways. How many was there in the beginning? 4 number of layers. So one you kept it as reserved and other three you made it at their permutation. So there are 3 factorial different ways. It's possible. Correct? So this is called the circular permutation. So difference between circular permutation and linear permutation is this. Because circular permutation, if you just rotate it, so their positions are same. So you have to fix one position fixed, and after that it will treat it as linear permutation. So therefore, we can have the formula: the number of permutation of n distinct object arranged in a circle is n minus 1 factorial. So there are n elements are there. Now one you have kept fixed, other n minus 1 you have done their linear permutation. So how many ways you can do? N minus 1 factorial ways. I hope it is clear to you. Now think of this example. You already know the answer for this. How many circular permutations are there of 4 persons playing bridge? So bridge is a game which you play with the cards. So how many different permutations are there of 4 person? Yes, one you have to fix it, and then therefore 3 factorial ways. So it's a circular permutation basically. Okay, let me move to the next example. This is the answer for this. We already discussed. There are 3 factorial equal to 6 different ways. Now, permutations of similar object. See, suppose I want to ask you that how many different permutations are there of the letter A, B, and A. Correct? Now look at this. Although there are 3 number of objects are there, among them 2 are the similar object A and A. Right? So in this case, if you do A, B, A, this is one kind of arrangement. A, B, another one. But you have taken the third one first and first one second and the second one third. But these two are the same, right? Because you have the similar kind of object. So this count should not be 3 factorial, right? So if you have such kind of cases, the formula for permutation is little different. The general formula is the number of permutation of n object where n equal to n1, n2 up to nr, of which n1 are of one type, n2 are of second type, and nr are of rth type, is given by n factorial divided by n1 factorial into n2 factorial dot dot up to nr factorial. Right? So you have n number of objects. Among them, n1 are of similar type, n2 are of second type, dot dot nr number of objects are of similar type. So then how many different number of permutations are possible? It is n factorial divided by n1 factorial into n2 factorial dot 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 up to nr factorial. We'll do a lot of example. It will be very clear to you. Let me move to an example. Now you know the permutation of similar object formula. So look at this example. How many different letter arrangement can be from the letter Pepper, P-E-P-P-E-R. So think of the example in the view of permutation of similar object. Make the video pause, try to write down the answer in your notebook or in the comment box, so that you will understand that you are understanding this concept. Yes, so altogether there are 6 number of letters are there. Among them, the letter P is of 3 times it is appearing. The letter E is appearing 2 times and R is appearing 1 time. And you have to find the letter arrangement, right? So there are altogether 6 objects. Among them 3 are of similar time, 2 are of other second type similarly, and the R element is of 1 end. So how many different ways? So this is the permutation of similar object. According to the formula, you have 6 factorial divided by 3 factorial into 2 factorial into 1 factorial. This many different type of letter arrangements are possible. I hope it is clear to you. It's a very nice concept, very easy one. you can easily understand where you have to apply this permutation of similar object. Yes, this is what we discussed. So there are 60 different arrangements are possible. Now think of this example. A hospital operating room needs to schedule 3 knee surgeries and 2 hip surgeries in a day. How many possible sequence of surgeries can be scheduled? I hope I don't need to explain this one. You can easily do this problem. Make the video pause, try to write down the answer in your notebook or in the comment box. Yes, so 3 knee surgeries and 2 hip surgeries in a day needs to be scheduled. So there are 5 different surgeries, right? And 3 of them are knee surgeries, so they are of similar type. So you should write 3 factorial into 2 hip surgeries which are of similar type. So how many different sequence of surgeries can be scheduled? So this many different sequence of surgeries can be scheduled. 5 factorial divided by 3 factorial into 2 factorial. Clear? Yes, this is what we have discussed. So there are 10 possible sequences are possible. Yeah, the similar example. Look at this. I hope I don't need to answer it. In how many ways can 2 paintings by Ratan, 3 paintings by Vargav, and 2 paintings by Sriram be hung side by side on a museum if we do not distinguish the paintings by the same artist? So what should be the answer? 2 paintings by Ratan, 3 paintings by Vargav, and 2 paintings by Sriram. So 2 plus 3 plus 2, it is 7. So 7 factorial divided by 2 factorial into 3 factorial into 2 factorial. So this many different ways you can do it. I hope you understand. So let me finish the content. That is what we have discussed. And we have all the most of the content we have taken from this book or from this book of this lecture. I hope you enjoyed the lectures. If you need any kind of different way of lecturing the videos, you can write down in the comment box. If you really feel the lectures are useful for you, you are really learning, you may also write down in the comment box. Thank you. Bye-bye.